All right. Good evening, guys.
Good evening.
Sorry for logging in late. Hey, oh, I was trying to send the questions to my other device. Seemingly, I'm only having one person. Okay, people will be joining as we are going. Okay. All right. So today, guys, we are looking at probability. We are looking at probability, like we discussed yesterday. We'll look at probability. Okay. So probability, it has two sections. It has the general probability and it also has fundamental counting principles. But for today, I think we have to look at probability. Then if we get another chance, we'll look at fundamental counting principles. Okay. So probability, right? Number one, we're gonna look at maybe definition, the definition of probability. Number two, calculating probability. Number three, gonna look at the rules of probability. Then number four, we're gonna look at uh, maybe Venn diagrams, probability tree diagrams, and contingence tables. Okay, that is what we are going to be looking at in the next hour. We just hope that our time is going to be enough for us to go through everything. Okay, so guys, I just want to remind you, probability doesn't have much marks. It has somewhere around, together with fundamental accounting principles, it has somewhere around 15, 12, 15, 12, 15. Probability on its own, without the part of fundamental accounting principles, it carries something like 8 marks. Okay, so it is important that we do it, because those 8 marks, they work out to shape your your score. Okay, so probability. What is probability? What is probability? The definition of probability. Probability, it can be defined as the chance of an event to occur. Right? It is the chance of an event to occur, which is measured, between 0 and 1. Okay, or let's say not between, but let's say from 0 to 1, where 0 is an impossible event, then 1 is an obvious event. Okay, right? So in probability, we have total possible outcomes. For example, if we toss a coin, we have two possible outcomes. It's either we can get a head or we can get a what? A tail. So the total possible outcomes are two. We have an experiment. For example, tossing a coin, it's an experiment. Okay, so we have a favorable event is the event that we are looking for. For example, if we toss a coin, if we say the outcome that we want is to get a tail, so what is the probability of getting what? A tail. Okay, so how do we measure probability? Okay, probability of an event, probability of event is written as P, then in brackets E. So it is equals to number of the event over number of the sample space over the number of the sample space. So probability, remember that it is measured from 0 to 1. So it means it is a fraction or a decimal that is less than 1, but greater than what? Than 0. So you can leave it as what? As a fraction, as a proper fraction, or you can leave it as a decimal. Okay? For example, e.g., we say a six-sided die okay, it's the dice name, is rolled. Like if you play dice, okay, the outcomes recorded. Okay, let A be odd numbers. Let B be even numbers. And let C be prime numbers. Okay, so let's check the total possible outcomes, which is the sample space. The sample space, we are going to get a six-sided die. We have 1, 2, 3, 4, 5, 6. Okay? Then event A, which is odd numbers. What do we get? What are the odd numbers that are there? It's 1. Then we have 3. Then we have 5. Then B, even numbers, 2, 4, 6. Then C, prime numbers, numbers that are divisible by 1 in itself, 2, 3, and 5. Okay? So a question can come and say, okay, I'm going to wrap the question itself. A question come and say, what is the probability of getting A? So determine probability of A. Okay? Probability of getting A. How many items do we have there in event A or in outcome A? We have 1, 2, 3. So that is number of A over the number of the sample space. So in A, we have 3 items over 6 items. Okay? So this is going to give us what? A half. So the probability of getting odd numbers is going to be 1 over 2. Okay? That is the probability of getting odd numbers, which is event A. We said event A is odd numbers. Okay? Then another question can say, what is the probability of getting a 3? Okay? So we can check from there how many 3s do we have? So it's going to be number of the 3s that we have over the number of the sample space. But we only have 1 3, so it's going to be 1 out of how many items? Out of 6 items. Okay? So it means the probability of getting a 3 is 1 over 6. Okay? So that is how we calculate probability, number of the favorable outcome over the number of what? Of the sample space of the items that we have in total. Okay? I guess that is just, that was done in grade 10. And that is it. Yes?
We have 3 in the sample, we have 3, in A we have 3, and in C also we have 3. We have 2 3. It's
no. Remember that these events, this is odd numbers. This is even. This is what? This is prime. Okay?
So what is the
So
question?
the 3, the probability of getting a 3. If we roll a dice, how many outcomes do we have? We have 6 outcomes, which is 1, 2, 3, 4, 5, 6. Okay? What is the probability of getting a 3? How many 3s do we have here? We only have 1 3.
1. Yes,
Yes.
1.
Out of what? Out of 6. What is the probability of getting odd number, which is probability of A? Probability of A. We did this one. How many outcomes do you have? 1, 2, 3. So it's going to be 3 out of how many? Out of 6, which is half. What is the probability of getting a B? How many outcomes do we have in B, even numbers? 1, 2, 3. So it's again 3 over what? 6. What is the probability of getting a C? How many outcomes do we have?
3.
Out of what? 6.
6.
You see that, ne? Are you corrected there?
Yes, sir.
All right. Now, oh, you were also confused. All right. Right, let's move on. Let's go to intersection. Let's go to intersection. Okay, we are going to talk about laws. Right, A and B, or it can be written as A intersection what? B, for example. So when we are talking about event A and B, it is a set containing common elements in set A and set what? B. Let me just change here, such that this one becomes A, this one becomes C, A, and B, so that we can suit this one. So intersection, it is a set containing what? Containing common elements in set A and B. Okay? So, e.g., from whatever that we are having there, A and B, what is common in set A and set B? What is common in set A and set B? Check there.
It's 3 and 5.
That is set A and set B. Set
Oh,
A
it's
and
2.
set B.
It's 2.
That is the intersection. Okay? That is what? The intersection. So we can write it as a probability. That probability of A and B is equals to how many items do you have in A and B? We have how many items?
2.
6.
This number is what? It's 1.
2.
This item is a single item. Ne? This number is single.
Yeah,
It's only
okay.
one number. Out of how many numbers?
Okay.
Out
Okay.
of 6 numbers. So
6.
probability A and B is equals to
Okay.
what? Is equals to 6. You get it now, ne? I hope the rain is not gonna interfere with our sound because it's raining now. Okay, so probability of A and B is equals to
Okay.
1 over 6. Okay, so if we can draw it on a Venn diagram, A and B is what is common in set A and set B. So whatever that is common, we call it the intersection. Intersection means overlapping of 2 items, right? So we see A and B are overlapping, and what is making them overlap? It is what? It is 2, right? It is 2, right? So that is intersection, which can be written as A and B, or it can be written as A and B. The N, which is just an N without this, okay, right? So we also have union. We also have union. Union, which can be A or B, or it can be A union B, like that. This means what? Union. Union consists of honorable member, can you please mute your mic? Okay. Union consists of outcomes that are in either set A or set B. For example, let's go. We had A, which was having 2, 4, 6. Then B, which was having 2, 3, 5. So what is going to be A or B? The union. Right. We see 2 is common there. So we are going to write it once. Then we have 3. Then we have 4. Then we have 5. Then we have 6. All the items that are found in A or B are there. We don't repeat this one to say 2, 2. It's 2 because it's common. So you take it once. So it's 2, 3, 4, 5, and 6. That is A or B. Okay? That is A or B. So representing it on a Venn diagram, A or B, it means all the items that are found in set A in set what? Or set B, like that. So that is A or B. All right. So I'm going with it. I hope where I started is going to help some people because I've started from far. Right? Then we have what are called mutually exclusive events. Who still remembers what mutually exclusive events mean? Let's interact, guys. Who remembers what mutually exclusive events mean? It simply means events that do not have common elements. Mutually exclusive events means events that do not have common elements. Some teacher says events that do not occur at the same time, we call them mutually exclusive events. Okay, guys, there's a lot of noise here. Can you hear me properly?
Yes, sir.
Yes, we can hear you.
All right. So these are events that do not have common elements. Let me give you an example. E.g., if you are having event A, which is going to be 1, 3, then we have 5, then event B, which is going to have 2, 4, 6. You see, these ones are called mutually exclusive events because they do not have common elements. There is nothing that is common in A and in B. So we call them mutually exclusive events. Therefore, since they do not have an intersection, we say the probability of A and B is going to be equal to what? 0. We don't have any element that is common in A and also in what? In B. So these are mutually exclusive events. Okay? Right? We move on, we go to the other one. Let us go to the probability rules. We have number 1, the general rule, which states that the probability of A or B of event, these are event A or B, is equals to the probability of A plus the probability of B minus the probability of A and B. That is the general rule. Some they call it the addition rule. Probability of A or B is equals to probability of A plus probability of B minus probability of A and B. Let me just write it proper. Yeah, that is probability of A or B is equals to probability of A plus probability of B minus the intersection, which is probability of A and B. Okay, so this one can be used in several instances. If we have this one, that one, and that one, we can get that one. So if we are given the other ones here, we can find the one that is what? Unknown. Then for mutually exclusive events, probability of A or B is equals to probability of A plus probability of what? B minus 0. Remember that we said mutually exclusive events are events that do not occur at the same time. Therefore, this one is what? This one is 0. So usually we don't write it because minus 0, there's no reason why we write the 0 there. Okay, so I want us to go to the last item that I've sent there, the last exercise that I sent, right? Which is saying this one is not, it's not good. Let's leave it like that. I'll find one that is actually good. This one is not good. But sometimes we can be given that probability of A or B is equals to 0.8. Probability of A is equals to maybe 0.3. Probability of B is equals to 0, let's say 0.7. Determine probability of A and B. That is simple. Probability of A or B, we have it 0.8. You substitute. Probability of A, you have it 0.3 plus probability of B 0.7. Then you work on it. Then you get your items. You'll be having an equation. Okay, let me just substitute it. So this is gonna be 0.8 is equals to 0.3 plus 0.7 minus probability of A and B. So this one becomes the unknown. We don't know it. So now this one is a what? An equation where we have 0.8 is equals to 0.3 plus 0.7. It's gonna give us that's gonna give us something like 1 minus probability of A.
Which question are you answering?
Sorry?
The question. What is the question?
No, I have gone to check. I've done my own this question.
Okay.
Yes, I've done this question here. That we are given that and that, but we don't have this. Okay. So from there, this is now an equation. How do we solve it? This one has a minus. We take it the other side. Probability of A and B is equals to 1. We take 0.8. Then it's going to be minus 0.8, which is equals to 0.2. So it means the probability of the intersection is 0.2. So that is how we use the general rule. The general rule, you might be given all the other ones except one. Then you can use the general rule in order to calculate. Hey guys, I'm having a lot of disturbances here. It's raining and I can't even coordinate what I'm doing. Is it okay? We can postpone maybe up to tomorrow.
No,
But,
it's not a
but
problem.
for
We
us,
can
it's okay.
postpone because
We can postpone
Hello?
if we can, but for us, we can
Sorry?
hear you properly. We can hear you properly. There is no problem.
But myself, I can't coordinate myself. It's raining. There's a
it's
lot of
Oh,
thunder.
no,
okay.
it's okay. You can stop. We'll
Yeah.
continue tomorrow, sir.
It's
All
fine.
right. All right.
Mm.
Okay. I'll talk to Sir Desmond. Then I'll do it tomorrow.
Okay, sir.
All right.